All right, hello everyone. Thank you for joining the webinar today. This webinar is going to be on the 2021 season wildfire forecast. My name is Bohan Lee. I'm a research associate with ICLR, and I'll be moderating this webinar today. So I'll begin with some logistical notes. Feel free to ask any questions that you have during the presentation using the Q&A button at the bottom of your screen. We'll be taking those questions at the end of the presentation. If you have any technical issues, please use the chat button and you can send a message to the host, ICLR, and we will try to help you out. So wildfires is a topic that's become more prominent in the past few years. I'm sure we've all seen the pictures from last year's really terrible wildfire season. And actually, a personal note for me, so I live in Ontario, but my parents live in Fremont, California. And it's not an area that's in a forest or anything. You know, you wouldn't think that it's at a big risk of wildfire. But my parents last year, they got a notice that they might actually have to evacuate because of the SCU lightning wildfire complex. And fortunately, the wildfires were contained, so they didn't have to evacuate during the middle of the pandemic. But you can see that this has certainly been a topic that's become more important. So with that, it's my pleasure to introduce Richard Carr, our speaker for today. Richard Carr is a wildland fire research analyst at the Northern Forestry Center in Edmonton, Alberta. He provides fire weather processing for the Canadian Wildland Fire Information System and international projects. Richard also provides fire weather briefings to the Canadian Forest Service Fire Group, the Canadian Interagency Forest Fire Center, and to federal emergency response personnel, and helps provide seasonal forecasting of fire risk. Additionally, Richard helps provide information to the North American Seasonal Fire Assessment Outlook and the North American Drought Monitor via AAFC's Canadian Drought Monitor. Finally, Richard represents Natural Resources Canada, Canadian Forest Service in the CIFFC Forest and Fire Meteorology Working Group. So now I will turn the floor over to Richard for the 2021 wildfire season forecast.
All right, thank you for the introduction, Bohan, and thanks everybody for attending this presentation. I think Bohan gave a fairly good introduction there, so I won't go over too much here, but as I was waiting, I'm just looking at the C and the ICLR logo at the bottom there, and the fire, of course, is behind the C, so I was thinking, well, sorts of words that, you know, the C could represent with fire, things like combustion and char and things like that, but of course it's catastrophic, and it's kind of interesting because a couple of years ago, Australia added another level to their fire danger, which is catastrophic. And they've all of a sudden got about 3 or 4 words here, I think, that mean much above the normal threshold. So things like severe, extreme, and catastrophic. And I was wondering how far that would go. Anyways, we'll get into the presentation here, and I'll just get back to my train of thinking that I should be following today. All right, I'll start with some background information, then we'll get into the actual conditions leading up to this season's forecast and the forecast itself. Just a bit of a history of wildland fire in Canada for the past 40 years or so. So we've got the number of fires, which is the lines on this graph, and the area burned is a histogram. So the area burned to read off the left-hand y-axis and the number of fires off the right-hand one. If you look at the early years here, we've only got blue bars. They were blue lines. So that comes from the Canadian National Fire Database, which is Natural Resources Canada product. So we've taken all the history of fires that we can get from the provinces and territories and compiled the area burned and the number of fires and plotted those. Now the orange bars and line come from CWFIS, which is Canadian Interagency Forest Fire Center. For anybody that's not familiar with that, it's located in Winnipeg, and it's a fairly small office, but it has a big role. So they coordinate all the firefighting resources, fire suppression resources between provinces and territories. and help arrange for international crews and equipment to come into Canada. So they do have a situation report that is updated daily through the fire season. And at the end, well, we get a tally of the area burned and number of fires from the provinces and territories. So you can see there are some differences. The National Fire Database at Natural Resources Canada actually uses some remote sensing area burned. So the numbers are a little bit different, but they roughly follow each other through there. At the very beginning of this graph, of course, CWFIS didn't exist, so we just have the Canadian National Fire Database. CWFIS was created in 1982, following those big fire years in 1980 and 81. So by 1983, they're actually producing numbers. If you go over to the very right-hand side of the chart, well, 2020 turned out to be a very quiet year, so we don't have the National Fire Database numbers in yet. It takes the better part of a year to get all the agency polygons in and analyzed. But we do have the CWFIS number there, which is very small, so probably got one of the lowest totals of area burned in this graph anyways. Might have been lower before this, but I think it's probably the lowest in the last 40 years. I guess just before I go ahead there, you see the trend of the number of fires currently heading lower. It's possible, but in the area burned is quite volatile. It's up and down a lot. I think over the past 10 or 15 years, you can probably see a trend to kind of a more consistent area burned each year. It's probably slowly rising. We don't have those huge spikes, but the general total each year seems to be going up. We do have better detection and suppression capabilities. And actually what defines a wildfire might have changed over the years as well. So there's some other reasons for those changing numbers. Over the past few years, we'll just take a look at how some of the fire seasons progress here. So we've got numbers from, I think, about 2014 on to 2020. So sometimes we have an early start to the fire season, such as 2016, the orange line, and just towards the bottom left-hand corner, you can see that 2016 Fort McMurray fire pointed out there. So very rapid increase in fire in the spring, and then it tended to level off over the summer and had a little bit of increase through the summer, but that came out a bit lower than the yearly average, which runs somewhere in the 2 to 3 million hectares area burned. We did have a lot of big fire years though, 2014, 2015. 2014 is a green line and 2015 is blue. So a lot of area burned in Northwest Territories in 2014, Saskatchewan in 2015. And of course, British Columbia had extreme fire years in 2017, 2018. By the time we get to 2020, though, it's a very flat line just right at the bottom in black there. So quite a different fire season last year. These are some of the charts that we produce on our situation report on the Canadian Wildland Fire Information System website. So this uses data from CWFIS. Just look at 2020. On the left-hand side is the number of fires. The red line is the 10-year average. And the blue histograms is 2020 values. So it stayed below average throughout the entire year. On the bottom is the area burned. So we came up with a very small total, about 8% of our average annual area burned. Of course, what we use for, I guess, a baseline figure does vary quite a bit. There are some groups that use 10 years, others that use 20. And of course, if we're looking at climatological data, we usually use a 30-year period. So maybe a bit of discrepancy about what period should be using, but quite often we're looking at either a 10 or 20-year period here. In this case, we're using 10 years. Anyways, on the right, the area burned, the histogram's just barely above the x-axis line, so staying very quiet throughout the entire year. All right, before we do the actual prediction for 2021, we'll just get into some of the starting conditions. We'll look at some of the climate influences. One is sunspots. it looks like we've just maybe come through another minimum, so probably 2019 or so. It looked like the sunspot count bottomed out, and it looks like it's starting to increase again. Now, the last maximum, probably 2012 or 13, it's quite a bit lower than the previous few, so still maxed out a little bit and sank again. We had kind of a broad minimum in 2009 or so, fairly similar, I think, with the recent one. But it is on the upswing again. I'm not sure what the forecast is predicting for sunspots. We do tend to get our warmer years through the maximum period or a little bit after, once it's on the downswing again. There's a bit of a lag time between some of these influences and what actually happens in the atmosphere. For the ENSO, El Nino Southern Oscillation and PDO, Pacific Decadal Oscillation, we do look at the surface temperature anomalies. For the ENSO or El Nino, the regions are shown there. We do have a bit of a blue plume out in the central Pacific indicating below normal sea surface temperatures. During the fully fledged El Nino or La Nina, that cold water plume usually extends right from South America out into that region, and it forms kind of a long arrowhead type shape. That's faded a lot over the past month or two, so we're getting back into a neutral condition there. We do have warm water forming along the west coast of South America again. It's kind of come and gone, but I think right now it's looking a little bit broader than it has been over the past few weeks. So definitely out of the La Nina now and back into neutral ENSO conditions. In the North Pacific, what happens along the west coast of North America is one of the signals of the PDO, or Pacific Decadal Oscillation. So when we have a fully fledged La Nina happening, we quite often get cold water along the west coast of North America. So that once again is formed fairly late in the season, but then faded again fairly quickly. So we just have a couple of blue spots up near the south coast of Alaska, or maybe far northwestern British Columbia. But I'm seeing quite a bit of warming up there again, and probably swinging back into more of a positive PDO phase. El Nino or La Nina, both extremes can cause fire problems in Western Canada. El Nino Southern Oscillation springs usually affect Western Canada, I think, more than the East. So in this chart here, we've got the ENSO history over the past 30 or so years. So values in red are El Nino, blue is La Nina. We've got some of the big fire years pointed out here. So with El Nino years, 1995, 1998, and Fort McMurray in 2016. And with strong La Nina, well, we've had big fire years in 2001 with Chisholm, Slave Lake in 2011. Over the past few years, though, these oscillations have been very quick. They haven't stayed in one phase for very long before swinging back the other way. And we do have some years pointed out highlighted in orange here. So British Columbia, for example, doesn't really depend on the El Nino or La Nina, but they seem to have big fire years in a number of neutral conditions. So 2003 is one, and then 2017 and 18 again. So we're heading back into neutral territory again here. So will it affect British Columbia this year? Well, we don't really have a good predictor whether that will happen or not, but it seems to happen about half the time, and the other half there's probably other influences going on. Pacific Decadal Oscillation, the top chart there gives the negative, which is in blue, and the positive, which is in red phases. So it has been fairly negative for the past number of years up until about 2013 or 14, and then the phase seemed to change. And it doesn't always stay in the same phase. There are little fluctuations, but we seem to have one phase dominating, so we're probably back into a positive dominant phase of the PDO. So we had the big fire years in 2003 in British Columbia, and of course recent big fire years in a lot of parts of Canada, Saskatchewan, Northwest Territories, maybe a few other areas. 2016 Fort McMurray, the El Nino seemed to coincide with the positive PDO, which probably aggravated things a bit there. In the east, just taking a cursory look at what the North Atlantic Oscillation does in comparison to Quebec years. So with the list in the center there, the years that are listed in red seem to have a fairly large area burned. So you multiply those by 1,000 to get the hectares burned. For example, 2013 has 1.9 million hectares burned in Quebec, so a very big year there. Moving backwards in time, 2010, kind of a moderate year, but still over that 300,000 hectares burned. It was a bit of an oddball year, I think, compared to the rest. I'll talk about that in a second here. 2007, roughly the same amount. 2005, fairly big. And 2002 is a big year again as well. Well, I guess what you might notice with a lot of these is that we tend to get into the positive phase of the North Atlantic Oscillation. There might be a bit of fluctuation between phases there, but 2010 seemed to be a bit of an anomaly with a fairly broad negative phase there. So just very cursory look, as I say, so, you know, not quite sure what to draw from that, but just at the right-hand side of the bottom chart there in 2021, we're kind of flipping back and forth between positive and negative phases again. With early snow melt there, it's, you know, certainly started off being active in Quebec, although there hasn't been a lot of area burned yet. Other things that we look at here are the snow depth anomaly in the spring on the left-hand side. So we've got lost snow cover in a lot of the provinces fairly early in the spring or even in late winter. There is still some lingering snow. I'm just going to draw some lines on here. So that red line gives the average 2 centimeter snow depth for the time of year. So if it's white to the north of that line, well, the snow is left early. And if there's color below that line, such as in extreme northern Saskatchewan and Manitoba, just a second, I lost my pen. Try that again. Just below that red line, we've had some lingering snow cover. We have had some snow events up there, which have added to the snowpack as well. So it's a bit later leaving in those areas. Certainly through a lot of the country, we've had snow cover leave quite early and some spring fire activity fairly soon on. On the right-hand side is the drought code from last fall. So we take a look at the drought code from the Canadian Forest Fire Weather Index System. It gives the moisture level on the deepest organic layers in the forest floor. So where it's red, it's in the highest category. There are very dry conditions. Look at the winter precipitation and then adjust this drought code for spring startup values. So we have fairly high values going into the winter and a lack of snow cover. Well, they come out quite high in the spring again. And we've seen that in southern Manitoba this year with dry conditions going in. Barely any snow over the winter. In fact, I think a lot of the area was quite bare over the winter, just had a very skimpy snow cover, which disappeared quite early. Recent precipitation on the left, these are maps from Agriculture and Agri-Food Canada, or AEFC. Now we've got the past 3 months precipitation on the left-hand side. So this map was taken from May 10th, so it's the percent of average. You can see a fairly large area through the prairies that's in red there, which is the lowest category, which I can't quite read, but it's you know, quite low for the time of year, and it's been dry through the winter and through the spring through a lot of that area. You see a bit of dryness around the eastern side of the Great Lakes, and then areas up through the north where the weather stations are a bit more widely scattered. You get some red dots up through the northern parts of Saskatchewan, Manitoba, and across Hudson Bay. On the right is a Canadian drought monitor that gets updated monthly. So this is the conditions from April 30th. It's usually posted by about the 10th or so of the following month. Over the winter, we've seen the drought area expand, and in fact, we see a lot more redder in that redder D3 extreme category through southern Saskatchewan, Manitoba. So that's gotten worse over the past month there, and the other categories are a bit more prominent throughout the prairies. We've seen that whole drought area expand a fair amount. And patch across the Ontario-Quebec border as well. Further north, it's been a little bit more kind of up and down, or the patches of yellow are abnormally drier there, but they tend to change shape, morph around a little bit, but haven't seemed to be getting much worse. All right, looks like I forgot to change the year on this slide here. This is actually 2021, so that should say 2021. Sorry about that. Forecast for ENSO looks fairly neutral. Now, this is a plume of probably 20 or so models here. The red lines, red horizontal lines there give the positive and negative 0.5 degree anomalies that characterize the El Nino or La Nina. So we need those for 3 months consecutively. So if the values fall above the top red line or below that bottom red line, well, we've got El Nino or La Nina going, respectively. If they fall in between these two red lines, then are in that neutral conditioning. Most of the model elements are fairly consistently predicting a neutral type ENSO throughout the year and probably into next winter. There is a bit of a hint with the latest forecast here from May, though we're seeing a bit more of a downturn in some of those models towards the beginning of next winter. What that does to our seasonal forecast, though, is that without any strong drivers, it makes things a little bit more unpredictable. All right, we're going to look at the North American Multimodal Ensemble here in MME. So this is a combination of American and Canadian climate models. The green box in the center there contains the two Canadian models. On the left is CAN CM4I, which is just an improvement from the CM4. Use CICE as one of the inputs. On the right is the GEM-NEMO Global Environmental Multiscale. The NEMO is a nucleus for European modeling of the ocean. So that replaces the older CM3. One of the things that we really struggle with here is completely opposite predictions from both of those two models. So those are both used in our seasonal forecast. So it, quite often the result is which one has got the stronger influence. Something else we do, though, is look at just visually assess the other models that we see here. The top left is the actual multimodal ensemble. The rest of them are the individual models, and at the bottom right, the IMME is the international multimodal ensemble. So that'll incorporate European models, for example. So here we're just looking at temperature forecast for June. See that GEM-NEMO has a huge pool of cool air that carries right across the country for June. Yet the CM4I tends to maybe follow along with the other models, predicting a bit of a warmer country, at least for the most part, except for the northwest part. So I think if you look at all the red on here, you can see that most of the models are tending to predict warmer conditions for June. Just the GEM-NEMO is carrying that really large pool of cool air through the month. We had in precipitation here, all the orange areas or red areas are where it's expected to be dry, and the green areas where things should be or expected to be wet. Once again, I think for the most part, the models here are predicting a lot of dryness. I think GEM-NEMO has got a bit more moisture, maybe over the Great Lakes and up over Hudson Bay, but definitely predicting dry conditions in the west. That seems to follow along with the bulk of the other models here. So with the North American model ensemble, top left there, just inside that pink circle, we're seeing the hint of dryness in the west there, maybe a bit in the east as well, and a bit more moisture over the Great Lakes and up towards James Bay. We have a similar result from the international multimodal ensemble, hinting at that dryness in the west, maybe a bit in the east, but it seems to have it maybe a bit further south. But still, it's not too often that we see models really suggesting these type of patterns together. So it's probably a bit of a confidence booster that what they're saying might be true. We go into July, well, we're still seeing the Gem Nemo carrying cool air through a lot of the country in July, and the CM4I predicting just the opposite with warm conditions. Precipitation, we get quite a different result between the two Canadian models here with the CM4I looking at dry conditions through a lot of the country, and the Gem Nemo predicting wet throughout most of the country except in the far northwest and maybe the eastern regions. But if we look at the North American Multimodal Ensemble, well, it's still giving that hint of dryness in the west overall. And the IMME at the bottom right, the International Multimodal Ensemble, tends to follow that pattern as well. Into August, once again, Gem Nemo carries that cool air right through the summer. CM4I has a lot more warm air, a bit cooler up through the maybe Eastern Territory, Southern Nunavut, and across Hudson Bay. But if you look at the other models, there's a lot of red out there as well. So most of the models are predicting warm temperatures through most of North America. Now, precipitation, which is harder to forecast, of course, still seeing a signal of dryness in a lot of the country from the CM4I, focusing on the southern prairies and Gem Nemo, and maybe directing precipitation a bit farther north up along the 60th parallel across the Great Lakes. Look at them all together, North American Multimodal Ensemble still tends to show a hint towards dryness through a lot of the country. We get that same pattern predicting from the International Multimodal Ensemble as well. We're going to go into September there. It just looks very similar to what we saw in August, so not really too much difference in the patterns. Must add, as we get farther out from the initial forecast time, well, the accuracy does drop off. So we'd have better confidence for predictions for, say, June and July, and maybe a little less confidence in August and September. So we'll take a look at how all those boils down into the NRCan seasonal prediction for the fire season. So just a bit of a background here again. I'll base this on the Canadian Forest Fire Weather Index System, or the FWI system. The items in red there, the drought code, we use that. I've talked about that. We use the fall values, adjust it for winter precipitation, come up with new starting values. What we actually do for the maps, though, is at the bottom right, you have the extension called the severity rating. We calculate daily values of that. Those can be rolled up into monthly or seasonal values as well. So we use a monthly assessment. So we calculate our FWI from all of the Canadian CANSIPS ensemble elements, compare that to a 30-year mean of the monthly severity rating. So we're comparing 1 month against the same month in this historical period. So I mentioned CANSIPS, the Canadian Interannual to Seasonal Prediction System. So the models are developed by the Canadian Centre for Climate Modelling and Analysis in Victoria, BC. Talked about the models a little bit, the CN4I and the Gem Nemo. There's what that acronym means spelled out. Each is a 10-member ensemble, so they each forecast out for a year, a 12-month period. We calculate our FWI on each of those ensemble elements, so we get 20 different forecasts. And we don't go out for the whole 12-year period, we really just look at the fire season, so we'll forecast out to September or October. We use temperature and precipitation data from these models. There is wind data available. We do have the code in our system here, we just haven't tested it out yet. Now, for the products, I might see two different kinds of things here. The map on the left there is a sample of what we get just from the FWI, or the severity rating forecast from the CANSIPS model. We may reassess a little bit using some of the other models that we saw from the national North American Multimodal Ensemble, pardon me. We also might assess current snow cover conditions and come up with line drawings like you see on the right here. We don't have those on the Canadian Wildland Fire Information System yet, just the maps as you see on the left. And just to note that this is a sample only, it's got no bearing on what our 2021 forecast looks like. But here is what we do have on the CWFIS. So the left-hand side is our May prediction. You see a lot of blue indicating below average or well below average conditions. Where we have the active fires in Saskatchewan, Manitoba, and Western Ontario, at the moment, we're kind of hinting at a normal fire condition throughout May, but it's certainly been a little bit more than that. And on the map on the right is what we've highlighted just based on having lack of snow cover, early snow melt, and continuing dry conditions. So we've created these line diagrams. So we do have a chunk of Alberta and a lot of the prairies highlighted in that. And, with that right-hand map, you know, earlier in the season, we actually did extend this through Ontario, and we did chop it off a little bit in this latest one. So we probably could have extended that a bit farther. So we do have a fair amount of active fire through that western chunk of Ontario there. We're also looking at that area across Ontario-Quebec border. So early snow melt, kind of ongoing dry conditions through that area so far this year. Once we get into June, I guess maybe I'll erase the ink off this slide since this doesn't apply, the scribble doesn't apply to June anymore. Now we do have that pretty much same area highlighted again. We didn't create a line diagram in this case, but we're starting to see those red values indicating above average conditions creep into a lot more of the southern parts of the provinces. And we do have that southern Manitoba, Western Ontario area highlighted with the red spots in southern Manitoba. Do note that some of this falls into agricultural land, so it may not be quite as susceptible to wildfire at certain times of the year throughout the summer, for example, when things tend to be growing and a bit greener. Once we get into July, well, we start to see the central part of the country really get highlighted again with above average or much above average conditions. So we're kind of seeing a hint towards, I think, the forecast of warmer temperatures, but especially I think that the dryness may be continuing through the summer. Starting to see other areas such as southern BC maybe start to get a bit more active as well. And British Columbia really depends on good June precipitation. If they get the rainfall there in June, well, they might not get too much active fire until later in July or in August, but if it stays dry through June there, well, 2017 was an example. Get into early July and have a little bit of lightning without too much rain, and things go up. And so it's I think June is it's a really critical month usually. August looks very similar, but a little bit more of the dark red. So a lot more of the country kind of highlighted into that well above average category there. I must add that even though the north looks fairly normal, I mean, there's a lot of area burned up there annually in average year. So even in a normal year, you can get some pretty good fires going up through the Northwest Territories and Yukon. There also is a spot on the east side of Hudson Bay, just where it bulges to the east a little bit there below the gray area. Just highlight that area as well. So it's quite often active fire through that area. So if it gets above average, well, there could be some fire through there. Not a lot of people, mainly, I guess, hydroelectric plants and maybe a few First Nations communities, etc. But the bulk of the population, of course, is much further south in the province, but still can be some serious consequences if you get active fire in that area. In September, well, we start to see things taper off as we should. Still pretty red through southern BC and a smaller area in the central part of the country, but still there. Through the northern areas, by the time we get into September, we're starting to get longer nights. Daytimes are usually less warm, so any nighttime moisture, dew, and any rain that falls can linger a bit longer. And even though you might get a hint at above average burning conditions, there might not be a lot of new fire up there. One consequence, though, is if it stays dry throughout the summer and you do get big fires burning in some of those areas, especially in peatlands, they can smolder for a long time, and some of those can actually smolder over winter and pop up the next spring. So one thing we may look at if it hints at above average conditions there is just what happens with existing fires if they're burning deeply. And certainly in areas like southern British Columbia, it can stay quite warm and dry throughout September, and quite often can get fires that are still active through September there and even well into October. Once again, in the prairies, we tend to get a lot of grass fires. We've had some fairly big grass fires in Alberta in the spring. And once you get into the fall there too, if it stays dry and warm and windy, well, you can get grass fires occurring there again. 2020 was kind of an oddball year with very little burned in Alberta, but we did have one active fire in October there west of Calgary that tended to burn more forest than all the rest of the fires combined throughout the year. So it was very unusual. Just kind of a couple of sample charts. We do produce these for a number of stations across the country that can help us assess conditions. So we're looking at Yellowknife, Northwest Territories here. On the left is temperature from the two models, the GEM-NEMO at the top, the CM4I at the bottom. On the right is the seasonal severity rating, so you can see how it increases throughout the year. There is a black line in there that gives the mean or the average value. So if all our pink lines are above that, well, we're getting warmer temperatures or higher severity rating. So with Yellowknife, it's in one of those areas where you're kind of highlighting a normal year. So you see the GEM-NEMO start off quite cool, then the lines go maybe up above the average later in the year. The CM4I at the bottom seems to hold them above average for most of the year. And consequently, the severity rating on the right there stays below that black line with the GEM-NEMO for the most part. And the CM4I kind of brings it up above that line. So kind of some elements are predicting lower severity, some are higher, so it just kind of averages out. On the other hand, Nepal and Manitoba have been in the midst of the central part of the country where we're expecting more volatile conditions through a lot of the summer. Now we see precipitation is on the left, so both the GEM-NEMO, I think, are predicting below normal precipitation. The CM4I is maybe not quite as extreme. It tends to hold a lot of those pink lines closer to the black line in the center there, but still the bulk of them fall below that mean value. Temperature on the right, so you can see that both models tend to predict warmer conditions through a lot of the summer for this region in Manitoba. Then when we put on the seasonal severity rating, we'll see a lot of those lines getting up above that mean quite rapidly and staying there. And that's the case for both models there. So I think any areas in those bright red that we saw in the previous maps, we'd have graphs that look like this with a lot of those severity rating lines going quite high. And on the Canadian Interagency Forest Fire Center, people can keep track of the daily number of fires and area burned. So if you just hunt out that national situation report, down at the bottom of those reports, we get the values there for each province and territory. So I'll give the last 2 years and then a comparison with the historical periods at the bottom. So anywhere from 5 to 25 years. Now, just grab this one from yesterday. So we've seen a fairly rapid increase in area burned through Manitoba and Saskatchewan and Western Ontario. So up until a couple of days ago, there's kind of fallen a little bit below average in most of the provinces, but with recent activity, it suddenly shot up above in Manitoba, I think Ontario as well. Just have to compare numbers with what you see at the bottom there. Alberta, they did have some active fires, so we're actually sitting fairly quiet for this time of year. Alberta seems to be the epicenter of big spring fires, and we had some activity, but not any of the really big events that we quite often see. So, maybe that May forecast isn't too far off, where we did have some activity, but it's not above normal in Alberta and the west. But as you get further east, it indicated normal and maybe under predicting a bit there. Just at the top there, the number of fires, 75%, the area burned, 185%. And that's shot up from, I think, slightly below normal to quite a bit above normal over the past week or so. On the Canadian Wildland Fire Information System, or CWFIS, our seasonal forecast maps can be found on the left-hand panel, just under monthly and seasonal forecasts. We also keep track of some of the other statistics on our wildland fire situation report, or that blue arrow points, so just below the link to the monthly and seasonal forecasts. Now we only update these weekly, so what you're seeing here actually represents things from last Wednesday's assessment. This week's won't be posted until tomorrow morning, so we're just doing this presentation just a few hours before the next one gets posted up there. The red on here gives the historical value, and the blue is the current years. So you can see Alberta's red bar is quite a bit above the blue one. So historically, we tend to have a lot more area burned by this time of year. Now, if you look at this tomorrow, probably tomorrow, say noon or so, we'll probably see Saskatchewan, Manitoba, and Ontario suddenly change quite a bit. All right, we're getting near the end of the presentation here, so enough graphs and maps and things, and we'll just talk a little bit about some of the other aspects that we must look at. Climate model limitations. Well, we've seen the extreme difference that two models can produce with the CM4I and GEM-NEMO. Also, as we get into a different month's forecast, as we get into the end of May and do the June forecast, well, we might get a fairly different result than what the previous ones have predicted. In fact, in the early part of the spring, early to mid part of the spring, we tend to get a lot of those climate oscillations weakening out or changing phase a bit. Therefore, the climate models may have a tough time predicting what's going to happen in the summer. As we get closer to the summer, of course, the forecasts become more accurate. That limitation in the spring, some people refer to that as the spring prediction barrier. I think we've maybe got past that now, and by the time we get into May or June, we're probably getting better predictions for the summer. Also, we see weather change partway through a month, so prediction may be good for the first 2 weeks and bad for the last 2 weeks, or vice versa. And of course, we might predict possibly volatile activity, high severity anomaly, but you may not get any fire. You really need something to trigger those fires before you really get the activity. So some of the patterns produce very little lightning. If you don't get the lightning, well, there's maybe a lot less fires and a lot less area burned. Also, human activity is a big factor. So if you reduce the human activity, which has possibly happened in 2020 and 21 due to the COVID pandemic, well, might be a bit less fire relating to human causes as well. I think 2016 was an interesting example when we had the big fire in Fort McMurray. Well, I think Saskatchewan perked up, paid attention to that. And even though conditions were very volatile there in 2016, they had very little fire during that same period. Got some conclusions from the presentation. We'll get the kind of weak climatic drivers may produce fluctuating weather patterns, and we're kind of seeing that return to neutral Enso conditions. There may be a flip-flopping phase in the PDO, and same thing with the eastern North Atlantic or Arctic oscillations. Model consensus points to maybe cooler in the northwest, dry southern parts of the provinces. Much of that dry and warm areas in agricultural areas, so it's not really prone to fire, but there's that strip in the southern boreal that we're seeing burning right now. So, parts of the central parts of the provinces may be the most prone to fire throughout this year. What do we get overall? If we look at a country itself, well, maybe it points to somewhat of a normal fire year by the number if ignition levels are normal. There's certainly in a normal fire year, we're probably going to get some provinces that exceed the norm, for example. So, possibly Saskatchewan, Manitoba, and Ontario, for example. But maybe a bit quieter through some of the northern parts of the provinces and up into the territories. A few points to remember. The number of fires in area burned, well, there's all sorts of numbers depending on the source and depending on the historical period that's used. Somewhere between 6,000 and 8,000 fires burning, and I think that number is actually coming down. We can see on the graph that the number has maybe come down a little bit over the past 30, 40 years, but there's maybe things like unattended campfires that don't get lumped into wildfires anymore at some point. That was done by some agencies. I don't really know how it's all handled these days, but they can be factors in the number of fires. 2 to 3 million hectares burned yearly. So, even if we get an average year, it's still burning a lot of forest. Doesn't matter if we have maybe a quiet year. Well, we can still have fires with serious consequences. You can have a fairly quiet year in one area, but if you get 2 or 3 weeks with fairly warm, dry conditions, well, you can get a fire going in that period and you can have some, interface events happen or things like that. Just urge everybody to check updates. One seasonal forecast is probably not going to tell the whole story for the whole summer. So check the first few days each month on Canadian Wildland Fire Information System. We usually have the seasonal forecast update done on the first working day of each month. We can let everything run automatically and they might be posted on the exact first of each month. But sometimes we like to take a look at them before releasing them publicly. Daily conditions, of course, people can monitor those on most provincial websites. Each province or territory has a section devoted to wildland fire. And of course, we have the CWFIS conditions as well that are both current conditions, observations, and forecasts, and those are updated daily. Just like to give thanks to all the agencies that have provided data that we use and any help assessing seasonal conditions. So you can see all our logos across the bottom there. Right, so that brings a close to the presentation. So I guess I'll just open it up to any discussion or questions.
Great, thank you so much, Richard. That was very interesting. And so it does look like we have some questions already posted. And again, just a reminder, if you have a question that you haven't posted yet, please, you can ask that in the Q&A, or you can also, I've seen some people send it to the chat system to the panelists. So I've been collecting those. But just to start off, first of all, a question about a clarification. When you say above average, how many years are you averaging over? Is it like over the past 10 years, or is it over the past 12 months, or how do you do that?
Yeah, okay. Well, we compare the severity ratings. That's based on a 30-year period. So we're looking at a 30-year history and comparing the current year's forecast with that 30-year period.
Great, thank you.
I've probably trimmed down the amount of background or related material in there, and maybe I should keep a few points like that on hand. I think that we use a 30-year history.
It's sort of a technical point. Are there forecast maps and data available for import into a GIS system? And is there also some documentation somewhere that would explain the resources used in this and how to interpret them?
Yeah, I guess to answer the the first question, I have to check with some of my other team members. We do start out with geotiffs of those areas, which of course can be brought into a GIS. We do have some web services where people can access certain types of data. I can't remember if the seasonal forecast is included in things like our web map service or feature service operation. Yeah, I'd have to check with team members to get a definite answer on that. Documentation and things, we do have some very basic documentation on the website, but it doesn't go into a lot of detail, and it's something that I realize that we probably have to do a better job with. At the current time, we're kind of reassessing our entire operation here. So we're working on what we call the Canadian Wildfire Information Framework, where first of all, we can maybe divide up kind of public-oriented content with more technical content. Will also allow things to maybe incorporate other types of data more easily. And kind of along with that, of course, will require much more rigorous documentation. So it is in the works, maybe just not to the level of what you'd like to see at the moment.
Great, thank you. So we do seem to have some additional questions come in. So one is that they're asking whether this means that the 2021 forecast is a warmer and drier summer. So the risk of fire events in the central and western provinces are more notably to the south. Is this sort of a weather and human activity dependent?
Yeah, it's really we're predicting where the fire weather could lead to more fires, but you have to have the ignitions to actually make it happen. Provinces like British Columbia, well, we got forest going right to the US border, and pretty much most of Ontario is the same way. Manitoba's got some patches down there where it's forested. Saskatchewan and Alberta, not so much really, just kind of isolated areas. So, so if you do have those red areas in the predominantly agricultural zone, well, you might not have any fire really, but in forested areas, the conditions could lead to more fire, but you still need the ignitions. I must add something else to that. We're not really predicting the number of fires or area burned. We're not predicting the lightning activity or the human activity here, but just where those fire weather conditions could lead to more fire. We do have another product that should be out in the next year or so, which is a fire occurrence prediction system. So we've got a team of our researchers that are working on both a lightning and human occurrence prediction models there. So at some point we'll be able to probably roll that into our seasonal forecast as well. I think maybe by 2022 it might be released.
And along those lines, we have another question asking about this year's beetle infestation, if that's been taken into account.
Oh, really? That's something we haven't looked at specifically with fire. We do have insect and disease specialists within the Canadian Forest Service, and there's certainly national maps of insect infestations. We haven't really built that into our products yet. We do have, I think, an internal tool where we could maybe take a look at that, but it's certainly not part of our public product at this time. But certainly, things like this may be added onto things like the CWFIS interactive map in the future. So, it's a possibility still, and that type of thing will probably come along as the Canadian Wildfire Information Framework is developed. So that's a 5-year project. We're into year 2 now. So, in the next 2 or 3 years, well, maybe you can see a few additional products like that showing up.
All right, great. I think we have one final question. Just asking about the low level of wildfires in 2020 that we saw, and if you know what sort of some of the causes behind that were, especially, contrasted with the terrible wildfire season that the US suffered.
Yes. Well, I think all the rainfall got directed up through Canada. That's probably the biggest reason is parts of the boreal forest, like the central and northern boreal forest, for example, up through northern Manitoba, northern Saskatchewan, and up into the territories. Well, if you look at a fire history map, that's where most of the burned area occurs year to year. Some of those regions had record amounts of precipitation over the summer. So the area that burned the most got the most rain last year. I should say the area that usually burns the most got the most rain last year. Yeah, so I think that was the biggest reason. There was probably a bit less human activity as well in the forest, both recreational and industry. So, you know, it probably contributed to less fires going as well. Just don't have, you know, numbers to give for human activity at all, but it's definitely, I think people are thinking that did help reduce the number of fires.
Looks like we just had another question come in. Do you know if there's any correlation between firefighting budgets and these forecasts? You know, do I guess, the firefighting agencies use these to help project resources?
It's a good question. You know, I can't really answer that myself. I'd have to maybe contact provincial or territorial authorities regarding that. We do, well, usually in April, we do a similar forecast through the Canadian Interagency Forest Fire Center, and a lot of the provincial and territorial people will participate in that one. Now, that's a month earlier, and the forecast maybe not quite as accurate, and I don't really know, you know, how they might use that for their operations over the summer. So yeah, the question you'd have to really direct to the provinces and territories.
So I think that just about wraps it up. I think there's some people asking about opportunities to participate in working groups with the industry. And I don't know if you want to share that here or if you want them to reach out to you directly.
Yeah, well, let's see. Might as well see what it's like here. I just want to see what the questions or comments are like. So. They're certainly open to reach out to me directly as well. With my emails on that slide that's up right now. That should be, the email should be good for now. We are probably going to change our domain again in the near future, but this email will be active still. So anybody can still get question answered through that email, probably for a few years, I think. It's funny because we still have active email addresses from 5 years ago, I think. And still contact us for the old ones. But,
I guess it's better to have them active for longer than too short.
Yes, definitely.
All right, I think that about wraps it up. So Richard, do you have any last words before we wrap things up?
Well, I guess, well, first of all, I'd just like to thank everybody again for your patience, and I guess when we're working from home, we have to sometimes deal with a few interruptions and things like that. So hopefully it wasn't too disruptive. I think, you know, there's some improvements that we want to make to the seasonal forecast, and we've got a number of them in mind, and they'll come about slowly. But you know, I think that's once again something that'll take place more under this framework effort. So probably look for maybe improvements over the next 2 or 3 years, I think. Hopefully each year I'll be able to bring something a little bit better. Thanks for moderating, Rohan.
Yeah, I'm glad. And thank you all for attending the webinar. And I guess with that, we can wrap things up. Thank you, Richard.
All right, thanks for technical support there, Mike, too, if you're still on the line. All right, well, it's a pleasure once again, and I'll probably talk to you at some point next year again, if not sooner.
Sounds good.
All right.
All right.
Thanks.